Welcome to 5-Minute BTech channel.
All right, let's jump right in. So what exactly is OS architecture? You can think of it like the hidden blueprint for your computer's operating system. This isn't about the pretty icons or the windows you click on. Nope, we're talking about the deep internal structure that decides how everything, memory, processes, the file system, how it all works together. It's really the master plan that keeps your entire digital world from falling apart.
So why should you even care about this stuff? Well, a good architecture is basically the difference between a system that just flies and one that, well, crawls. It has a huge impact on speed, it determines if one tiny error can crash your whole system, and it makes it way easier for developers to patch things up. And maybe most importantly, it's the bedrock of a secure system.
Okay, so in the world of operating systems, there are really 4 big ways to build one. 4 main design philosophies that have shaped pretty much every device we use today. We're going to break them all down. The classic monolithic, the super secure microkernel, the very orderly layered approach, and the one you're probably using right now, the hybrid.
First up, let's talk about the OG of OS design, the monolithic architecture. And yeah, the name kind of gives it away. It's all about putting everything into one giant, powerful unit. So the key idea here is something called kernel mode. Just think of it like the absolute VIP lounge of your operating system. It has the highest level of privilege, it can talk directly to all the hardware, it's the boss. And in a monolithic system, everything, the file system, memory management, all the device drivers, it all runs together in this one powerful space. It's basically one giant, super integrated program.
And this really shows you the big trade-off, right? On one hand, because all the parts can talk to each other directly, it is incredibly fast. There's very little overhead. But, and this is a huge but, the downside is massive. A single bug in one tiny part, like a graphics driver, can cause that infamous blue screen of death and bring the entire system to a grinding halt. It's a real all-or-nothing situation.
And believe it or not, you've definitely used monolithic systems. The entire family of Unix-like systems, which includes the absolute powerhouse that is Linux, is built on this model. Even good old MS-DOS was a classic example of this super fast but kind of fragile design.
Okay, so let's switch gears and look at the polar opposite, the microkernel. If monolithic is all about putting everything in, the microkernel approach is all about taking almost everything out.
The whole philosophy here is minimalism. The idea is to strip the kernel down to its absolute bare-bones essentials. We're talking only the most critical functions that have to run in that privilege mode. The goal is just to make that core as tiny, as simple, and as secure as humanly possible.
And you can see that separation perfectly here. Inside that teeny tiny kernel, you've just got the basics, scheduling and communication. Everything else, your file system, network drivers, graphics, all of that gets pushed out into what we call user space, where they just run as separate, less powerful programs. Now, the payoff for this is huge. If a device driver crashes out there in user space, it doesn't take down the whole OS. The system is just way more stable and secure. But, of course, there's a catch. All these separate parts have to constantly send messages through the kernel to talk to each other, and all that chatter adds overhead and, well, slows things down.
You'll find this architecture in systems where reliability is everything. Think QNX, which is used in cars and critical medical devices. And what's really interesting is that even though it's not a pure microkernel, Apple's macOS actually borrows a lot of these ideas to improve stability, which kind of gives us a little hint about where we're headed next.
All right, on to our third style, the layered approach. This one is all about structure, order, and building the system up piece by piece, kind of like a stack of Legos.
The logic here is actually pretty simple and elegant. At the very bottom, you have layer 0, which is the hardware itself. Then, each layer above it is built only on the services from the layer directly below it. So memory management talks to basic operations, which then talks to the hardware. It's a really strict top-down hierarchy.
The great thing about this is how clean the design is. It makes debugging a whole lot easier because you can test each layer by itself. The downside, though, is that this rigid structure can be pretty inefficient. A request from a user way up at the top might have to pass down through a whole bunch of layers just to get anything done, and that can really slow things down.
So while you won't really find this in the big commercial operating systems today, the layered approach was a massively influential idea in academia. You saw it in systems like VOS and some early versions of Unix, and it really proved the value of having a well-structured design.
And that brings us to our final and by far the most common architecture you'll see today, the hybrid model. This is the pragmatic approach. It basically asks, hey, why choose just one when we can take the best parts of both?
So yeah, the name of the game here is balance. A hybrid kernel takes the speed of the monolithic design by running performance-critical stuff like your graphics drivers right inside the kernel. But it also takes the stability of the microkernel design by running other services as separate modules. It's a clever mix and match.
The result? You get a fantastic blend of performance and stability, which makes the whole system super flexible and scalable for what we need today. The only real catch? Well, as you can probably guess, mashing two different design philosophies together makes the whole thing a lot more complex to build and to test.
And chances are, this is the architecture you're using at this very moment. The Windows NT kernel, which is the heart of every modern version of Windows, is a classic hybrid. And like we mentioned before, Apple's XNU kernel in macOS also follows this model, blending that monolithic speed with microkernel stability.
Okay, so let's wrap this up with a quick summary. Think of this as your ultimate cheat sheet. Monolithic goes for performance over stability. Microkernel does the exact opposite, putting stability over performance. The layered approach values a simple design more than flexibility. And finally, hybrid aims for that sweet spot, balancing everything even if it makes things more complicated.
And that really leaves us with a fascinating question to think about. As our technology evolves with things like AI, quantum computing, the Internet of Things, is that balance going to shift? Are we going to need even more security? Or maybe even more speed? Or is something totally new, a completely different architectural blueprint going to emerge?
If you liked the video, hit like and subscribe to the channel, and I'll meet you in the next video.